Welcome back, and we are on lesson 11.4, surface area of pyramids. Our essential question: how can you find the surface area of a pyramid? So what you need to know is to find surface area of a pyramid, I do not have one specific formula like I showed you in the last video for prisms. Okay, so unlike this guy right here, okay, I'm not going to have one of these. I have to break the pyramid down into its shapes. Now, the good news is with pyramids, it's really whatever the shape of the base is, and then the rest is triangles. So if you go to page 615, page 615, all right, that's where 11.4 is. And they're talking about some pyramids, the fact that they're not just in Egypt, they're also in Mexico. So they're looking at, or Kara is looking at a model, to make a model of the Pyramid of the Sun for a history project. The base is a square with a side length of 12 inches, all right? Each triangular face has a height of 7 inches. What is the surface area of Kara's model? So if this was our pyramid up here, I tried to draw it 3D so you could kind of see it, not that I did a very good job. So let's pretend that this triangle here, right, really this triangle, that's our front face. Here on the side, I have a triangle. Really can't see it, and if I didn't draw this right because you wouldn't be able to see it, but there's a triangle on the back, on the far side over here, and then there's going to be one in the back over here. Now they said that our base is a square, so right here is the net, all right? So here is the net of that 3D figure. So I have the square base, and then 1, 2, 3, 1, 2, 3, and the fourth triangle would be in the back. So let's look what they tell us. They say the base is a square with a side length of 12 inches. So this is 12 inches, this is 12 inches, 12 inches, 12 inches, okay? And really the only other thing you need to find this surface area, I need the perpendicular height of one triangle, if assuming all four of these triangles, since it's a square, the four triangles are the same. And so they tell us each triangular face has a height of 7 inches. So that's what they want us to put here. So this height is 7 inches. That's all we need. So we label the dimensions on our net. Now find the area of the base and each triangular face. So the base, it's a square. They're using the formula for area of a square, where area equals S times S. Again, if you don't like that, you can use length times width, base times height. Remember that they're all, the length and width would be the same. So side length or length and width, whichever one you want to call it, is 12 to the second power, or 12 times 12, which would be 144 square inches. Okay, so over here, fill in your notes, substitute 12 for your side length, all right? Now, a face, let's do one triangle. Triangular formula, area equals 1/2 base times height. So our base is going to be 12, our height is going to be 7. So 1/2 times 12 times 7. And they used just parentheses. If there's no operation in there, parentheses next to each other all mean multiply. So 1/2 times 12 would be 6. And I know that 6 times 7 is 42 square inches. Now, what you can't forget is that I have 4 of these. All right, I have 1, 2, 3, 4 triangles. So I need to take, they're putting all the pieces together down here. So here's the plus sign. So that's, they're going to give us the 144 plus 4 times the 42 is what they're doing there. Pull out your calculator. We have 4 times 42. That's 168. So they want us to show 144 plus this part is my 168. So 168 plus 144, and I get 312 square inches. So the surface area of her triangular pyramid is 312 square inches. If you flip over to your next page, page 616, we're going to do one more example together. And I want you to be careful of this. I don't know why they throw this in there exactly, but it's lateral area. So lateral area is the area of all of the sides and not including the base. Okay, so sometimes you need to find the total area of the lateral faces of a solid figure, but you don't need to include the area of the base. So don't include the base. The lateral area, L, of a solid figure is the sum of the areas of the lateral faces. All right, so this is an example here. Quan is making a tent in the shape of a triangular pyramid. Okay, now remember, pyramids are named by their base. On the other page, I had a square pyramid, base was a square. Here, it's a triangle. All right, so this triangle down here is my base, and then I have triangular sides. So the three sides of the tent are made of fabric, and the bottom is going to be left open. So basically our tent is just sitting on the ground. And that's why we just want lateral surface area, because there's not going to be a base to find. The faces have a height of 10 feet. So right here, perpendicular to our base of our triangle. And the faces, and the base, so the faces have a height of 10 feet and a base of 6 feet. What is the area of the fabric Quan needs to make the tent? So 6 feet, 6 feet, and they don't tell us, but they're saying that all three sides were 6 feet, all right? So they want us to draw a net, and I think that is important for this. So I'm going to draw an equilateral triangle. So 6 feet, 6 feet, 6 feet. Then we have these faces coming off of each one of those triangles, okay? And it doesn't matter to me, the net's not perfect, it's fine, okay? And what's really important is this perpendicular height is 10 feet. And remember, we're not finding this area because we just want the lateral faces, so we're not going to worry about that, okay? And I can't because they don't give me enough information. I don't have the perpendicular height in here. You know, have to be here or there. I don't have that, so I can't find that part, all right? They want us to shade, well, what I did was actually shade the part we're not doing, sorry. Find the area of one of the lateral faces of the pyramid. So it's a triangle. I use formula for an area of a triangle, 1/2 base times height, and substitute. Our base is 6 and our height is 10. So 1/2 times 6 times 10. Half times 6 is 3, and 3 times 10 would be 30 square feet. Now, remember, I have 3 of them, so they're using L for lateral surface area. I still just say surface area equals. And we're going to have 3 times the 30, which is 90 square feet. So he needs 90 square feet of material to make his tent. All right, I actually do have one quick example here because, again, they keep throwing in these strange things that you need to realize when you read the problem. So on page 617, our next page, I want us to look at number 2 because they throw something more at you. It's actually simpler, but you just got to realize what they're giving you. So a triangular pyramid has a base with an area of 43 centimeters squared and lateral faces with bases of 10 centimeter, height of 8.6 centimeter. What is the surface area of the whole pyramid? So they want the whole thing, including the base. And you got to realize it's going to be a triangular pyramid. So I don't do well at drawing these at all. All right, so this would be my front triangle. The side one, you really want to see that back there, should be dashed in the side. All right, and so what they're telling us is, I'm going to shade this in. All right, that base, they're actually giving us the area of it. You don't even have to calculate it, all right? So the area of this base of this triangle is 43 centimeters squared. So all you have to do is find the area of one triangle, and they're giving us that perpendicular height of the triangle of 8.6 centimeters. And they're telling me the triangle has sides of 10 centimeters. So I just need to find one triangle. A equals 1/2 base times height. Area equals 1/2 times base is 10. Perpendicular height was my 8.6. So A equals half of 10 is going to be 5. So if I take my calculator, 5 times 8.6 equals 43. All right, so 43 centimeters squared. Well, that's kind of strange. It matches that. It's kind of funny that they did that. Now, I have 3 of these though, all right? So I have 3 triangles on the side, so I have to multiply that by 3. Plus, I have to add on this 43 up here. So really, I actually end up having 4 times 43, but we'll leave it as a 3 times 43 equals 129, and then add another 43. I get 172 centimeter squared. All right, so the whole point of this was be careful that sometimes they're going to give you an area as part of the problem already, so you don't have to figure out that piece, but you have to add it in to the other parts, the faces, the lateral faces that you were finding. All right, so for your work in class there, I'm just going to have you finish out 617, I believe. So we can come up and you can do, number 1 is started for you, which is kind of nice. So number 1 on that page, number 3, you can do 4, 5, 6, you can do 7. See how much time you have. And I think I'm just going to leave it at that. Now, the thing I don't like about the book examples is that they give you all square pyramids. They don't give you other shapes, which I guess I kind of get, but we did do the example here with a triangular one where they gave you the base already. So 1, 3, 4, 5, 6, and 7 on page 617.